to do a little more on my background, I was a teacher for 13 years, and then by then I was pregnant with baby number 3, so I decided I would stay home, and that was fun, and I did that for 14 years, but I also, during those years, I was a volunteer at their elementary school, and then their middle school, and then their high school, and I loved doing that. To me, being in the classroom was like, to me, being back in a school was like my second home. I just loved helping kids learn. And so, and even when my kids finished going through all of school and were off to college and stuff, I kept on volunteering, and I thought, okay, at some point I need to just stop. So I stopped for a little while, and then I came back again because it's just pretty cool. I love helping kids learn. After those 14 years of being a stay-at-home mom, I did go back to teaching for 6 years, and at some point I stopped. And in those 6 years, I realized that kids, there's just so much coming at them, and we speed them through so many math topics and so many English topics and so many everything, and that's just the teachers don't choose to do that. It's like the education department, the national education department, you're supposed to hit all of these topics, all of these standards. Well, that's hard on kids, and yet the teachers can't really slow down because they're supposed to cover it, and so they're kind of caught in the middle, and students are caught in the middle, and we're in this unhealthy situation sometimes. So I like helping students to be able to learn things. And one of the things I realized was they learn it, and then they dump it out of their brain because they're learning the next thing, and they dump it out of their brain, and they learn the next thing, and they dump it out of their brain instead of holding on to it. And how was I going to stop that? So one of the things I did was come up with lots and lots and lots of sets of flashcards, so that on about every topic, you name a topic, I'll probably have it. But I could break the kids in my classroom up into small groups, and then they could work on sets of flashcards. If they're in a class of 25, they know they can just sit back and let other people volunteer the answers. But when they're in a group of 4, it's kind of obvious they should be participating. And somebody gets to be the card flipper who doesn't have to do the problems. All the answers were on the back. So that was a really wonderful thing. Everyone wanted to be the card flipper. So then I had to make it be like after a few minutes, then you shift, the next person gets to be the card flipper and all that stuff. I also reminded them, do you know who Michael Phelps is? And he's the greatest swimmer of all times and da-da-da. And when he practices, and he's been in Olympics a few times, and when he practices, though, he has to have somebody go up against him, even though no one in the world beats him. So if you have a Michael Phelps in your group, don't worry about it. They're gonna finish the round, and they're gonna be the card flipper, and then you'll be against somebody else who's not Michael Phelps. So that, and in my classroom, I had some Michael Phelps kind of kids. So I just had to put in a plug for them. Let them be as smart and as fast as they want to be. Don't get mad at them. Just be as fast as you can be. Once I finished teaching and said, okay, I think I'm done, then I thought, it'd be nice if I could take all my hundreds of sets of flashcards and put them on a website. So my son said, Mom, I could do that. Okay, good. So he coded it all, and that's what one of the things we'll use tonight is my website, monumentalmath.com. It's free. I paid for it. I paid for the development. I pay for its ongoing commitments, and so I just turn it around to be free to anyone in the world. So I'll show you that, and I'll show you how it can be very helpful to you. Tonight, on your first one, it tells you we're going to do conquering integers, and then we're going to do equations, and then we're going to end with graphing. On the flip side of that is my little bio, and then she nicely printed out my advertisement of here's my website. I have 8 math game apps. They've been downloaded in 60 countries of the world and over 50,000 times. And the first one just became available on Android, and they're all free. So It's my service project to the world. And then I also have an account on something called teacherspayteachers.com, where I have worksheets up on there and people can buy them and download $1.50 and get my worksheets, and then that teacher can use them forever. So I like it that I'm helping people around the world, and I like helping you understand math a little more. First topic we'll do is integers, which is means positive and negative numbers. Integers are complete numbers, not like 5 1/4, 5.2, no decimals, no fractions. It's just numbers, complete numbers. So -4, -5, -10, -100, that kind of thing. Okay, so when I taught, I won't make you because you're eating, but when I taught, most of my years were at middle school, some were at high school, and most of my volunteer years were actually at elementary level, but I loved them all. So I would have my students get up and I'd say, where you're standing now is 0. When you go to your right, that'll be +1, so take a step to the right. And so then they'd do that, and then I'd say, now that's like +1. How are you going to get back to 0? So they'd take a step back and they go, I just took the step. Okay, but we're going to call that a number, we're going to call that -1. So if you add +1 and -1, you get back to 0. What if you added +2? What would you need to get back to 0? And they know, okay, -2, okay. Now, what if you added +2, but then you went past 0 and you added -5? And so and I go, you're doing really good dancing. And so they were like, yeah, right. You know, because they're middle school, they don't want that. But anyhow, so it kind of taught them, though. They got to be out of their seat and kind of enjoying it a little bit. Maybe they wouldn't admit it, but maybe. Then another thing I would have them do is to work with checkers. And if the students could come up and just stand around the table, that'd be great. So the red checkers are -1s, and the black checkers are +1. So the thing that confused kids was like, sometimes the answer is positive, sometimes it's negative. I don't understand why. And so then I would say, well, this might help. And different strokes, different things help different people. So if you have a +4 and a -3, that'd be 3 of these. But a +1 and a -1 becomes 0. And a +1 and a -1 becomes 0. +1 and a -1 becomes 0. So what's left? 1. Positive or negative, and be positive. And so then they'd go, okay, but what if you had -5 and a +2? Okay, then a 1 and a -1 becomes 0, 1 and a -1, and your answer became negative. Can somebody explain to me, how do you know when the answer is going to be negative? And they would say, when there's more of the reds, the answer will be negative, and when there's more of the blacks, the answer will be positive. Yep. And so then I'd ask them, how can you look at it and see it? And they would say, well, you could just have 5 of them and you subtract away 3, and what you're left with is 2. So even though the problem was addition, your brain needed to subtract. That kind of confused them too. But if you do it well enough, or if you do it enough times, you go, I'm getting this, I like this. You know, it might take somebody 6 times, it might take somebody 16 times. Is that okay? Absolutely. Another thing I would do, go ahead and stay here. Another thing I would have them do is work with decks of cards. And the blacks were positives and the reds were negative. And they got to, oh, I didn't take out all the face cards. These have them all out. So I would have them play war. So like this person would turn over 2 cards and they'd multiply, and this person would take 2 cards and multiply. That person got 5 sets of -5. Well, if you have I'm not going to take the time to do 5 sets of them. But if you have 2 sets of -5, what's the answer? 2 times -5 would be? -10. So 5 sets of -5 would be -25. So this person has -25. 4 sets of -3, -3, -3, -3, -3. 4 sets of -3, 4 times -3 becomes how much? You're also quietly polite.
Are you calling on a specific person?
Pardon?
Are you calling on someone to answer?
Anybody.
Okay, that's going to be -12.
-12. Then they had to decide, okay, who had the bigger amount? Is -12 bigger than -25, or is that bigger? Okay, and so here's the next thing. If you're in debt, 25, is that better? Or if you're in debt only 12, is that better? Which one would you want to be? Most of the kids would say?
12.
Yeah, -12. So -12 is higher then. And so they would play war and they would see and they'd win and stuff. Of course, it wasn't really any skill because it's the luck of the draw, but that's okay. It would, again, I could put them into small groups and their turn would come around faster and they could practice. They could go as fast as they wanted to. Or some kid might go, how are you getting this? And then those kids might teach them, or they might call me and I'll show them again or something like that. Okay, so what do you think? You want to practice positives and negatives with checkers, with decks of cards? Why not? Okay, while you're up here, and you can even stay standing, you don't have to do war, just who's got a bigger one? If you've got -5 and you've got -3, which card is higher?
-3.
Yeah, -3. Get them out of the way, go again. Oh, they're both positives. Well, I think of 5. Okay. +9 and a -5.
The 9.
Yep. Okay. So it'd probably be smarter to pull out a pile of your reds and a pile of your blacks so that you don't get positive times positive. I mean, that's just too simple. Okay. Yes, no? What do you think? Would you want to practice with cards, or you got this? You tell me. Pardon?
I think I have it down.
Okay.
Yep.
Good. Cool. On to the next thing. You can take your seat. Okay. Okay. Even if you didn't need it, if you think, okay, that verifies why a -5 plus a +2 is a -3, good. Okay, on to the next thing, your next page. So you've got a page on there where it gives you positives and negatives. And then it says using checkers, using a number line, which I did not show. That first problem is a +6 plus a -4. So if you start at 0 and you go +6, but then you back up 4, you are at 2. A +2. So some people like a number line better. Then using decks of cards was good. And then using the idea of money. Problem number 2, a -6 plus a +4. If you're in debt $6 to your sister and you pay off $4, now what's the situation? What's the situation? If you have $6 of debt and you pay off 4, now what? No problem. Pardon? Okay. You would still have $2 of debt. Okay. How about if you were in debt to your sister for $6 and you're in debt to your brother for $4, what's your situation?
Sorry, what was the question?
It's on the paper. If you're in debt $6 to one sibling and $4 to another sibling, what would be your situation? Yeah, you'd be in debt, huh? Yep. Okay. Thinking money is good. The only problem with that, the only issue with that is a lot of like middle school and not younger, their parents pay for everything. Their parents use debit cards or credit cards, so there isn't a whole lot of cash. They don't necessarily pay any bills. and they don't necessarily have debt. But if you understand the concept of debt, it can help you make sense for integers. Okay, let's do the next page in the handout. The first problem, these are two-step equations. 2x plus 9 equals 19. 2x plus 9 equals 19. Put a finger over top of the 2x. So now the thing is, something plus 9 gave you 19. What's that something? 10. So then you can take your finger away. 2 times what will make this be 10? 2 times what will make it be 10? 5. Okay, next one. Cover up the 2x. Something plus 24 gave you 46. So what plus 24 would give you 46? Think money. If you had $24, you wanted to get to 46, you still need how much? Okay, $22. So now you can take your finger off. So the 2x has to be 22. 2 times what will make it be 22? 2 times 11. Yep. Okay. Next one, 5x plus 10 equals 35. Cover up the 5x, make your brain, just make it be a math problem. What plus 10 would give you 35? 25. So what's under your finger has to be 25. So 5 times what would be 25? X must be 5. Yep. Okay. And I know your teachers teach you subtract on both sides and divide on both sides, but you're in senior high. I think it'd be really good for you to, you know, even if you go into calculus or physics problems and stuff, they're kind of complicated at the beginning, but they all come down to solving 2-step and then 1-step equations. So it's really good to, by the time it's down to a 2-step equation, to just be able to use mental math and get there. Okay, the next one, cover up your 5x. What plus 15 makes 60? What plus 15 would make 60? 45. So then underneath your finger was 5x. 5 times what makes 45? 9. Yes, so the x would have to be 9. Okay. Then my next one is on the board, and I call it candy bar method. Do you have a pen or pencil to write with? If you don't, you're welcome to come up and get one that's up here. Okay, so candy bar method is this. Never mind, that one's not working. Draw a rectangle by the problem, and you're going to break it into 4 parts. Doesn't have to be pretty. Okay? This number, whatever it is going to be the x. It's got 4 parts. 3 of the parts make 6. So now, algebra makes you have to analyze and go backwards sometimes. 3 numbers that add up to 6, so each number must be 2, which means all of them are 2, so go ahead and write those all in. So that x must be all of these 2s, so x must be 8. X must be 8.
You make this look so simple. Where were you when I needed help?
What's that?
I said, where were you when I needed help in college?
Teachers didn't do this for me either.
You make it look so easy.
Okay, good. Okay, the next one, 3/4 of a number is 12. There's 4 parts, so 4 is an easy thing to split it into. Okay, 3 of the parts make 12. Therefore, each part was 3 parts made 12, so each of those parts was 4. So go ahead and put a 4 in each one. So if x was all of those 4s, so x is?
Why wouldn't it be 3?
I don't know. Okay. Thank you.
That's 3 times, yeah. At least knew that much.
Woo! Okay. Now I'll put a paper bag over my head. Okay. So 3 parts made 12. Oh, it was 4. Never mind. Okay, 3 things made 12, so they were each 4. So then this was 4. So then the whole thing is 16. Yeah, you're thinking 3/4, yeah, 3/4 of 12. Whew. Okay, next one. 2/3 times a number is 12, so candy bar, you break it into whatever the denominator says. So 3 parts. 2 of the parts made 12. So then these 2 parts must each have been 2 parts, yep. So each part was 6. So then that extra part was also 6, because when you if you cut a pie into 3 parts, you're going to want equal parts. Okay, so 3 times 6 is what x is, so x must be 18. There you go, yes. Okay, next problem has thirds again. This whole thing is x. There's got to be 3 parts. 2 of the parts will make 24. So each part is, how much? 12, which means every part was 12. So then the whole thing is 10, 10, and 10, and 2, 2, and 2. Okay, 36. Okay, now the next problems, you're going to go one step harder. Okay, put your finger over top of the 1/3 x. Okay, what plus 5 makes 9? 4. So this had to be 4. So 1/3 x had to be 4. 1/3 of what would be 4? So there's thirds, and there, that's kind of bad. 4, 1/3 is 4, the other thirds are 4. So the whole thing must be 12, okay? Okay, next one. Put your finger over the 5, 6, x. Now just look at it. What plus 8 makes 28? 20. So this had to be 20. 5, 6, x equals 20. And then it becomes just like the problems that we just did. So if 5 parts made 20, we can do candy bar method. There's 6 parts, cut it in half, then make those be in thirds. That's 6. If 5 of the 6 parts make 20, how much was each part?
4.
4. Good. So then when I'm teaching it, I put it in every one just so that I know what I'm doing, and I teach students to know what they're doing. So 4 times 6 would be? How much?
24.
24. Okay, next one. You cover up the part with x. 9 plus what makes 24? Must be in the teens. What 9 plus what would make 24? You have an answer?
Okay, 9 plus what equals 24?
9 plus what makes 24? To subtract 9, subtract 10, that's easier on our brain, and then add 1 back. 15, yes. So this part had to be 15. So 3/4 x equals 15. So now I'm at candy bar stage. There's 4 parts. My candy bar is 4 parts. 3 of the parts make how much? 15. So that's why I write this here. Then I go, okay, 3 times what would make 15? What's the number inside of there? 5. So the entire thing is 20. One more of these, and then I'll have you work in small groups. Cover up your 2/3 x, and you've got 12 plus something equals 18. What's that something? 12 plus what? 6, yes. So this has to be 6. So 2/3 x equals 6. Then make your candy bar. Your denominator tells you how many parts to break it into. 2/3 x. So 2 of the thirds makes 6. 2 of the thirds makes 6. So each of those parts must have been 3. So then the whole thing was?
9.
Yes. Good. Okay. I have lots of sets of flashcards. So I have sets where it's just the 1 step, and then I have sets where it's the 2 step. So, and then I have another 2-step one, and it looks harder, but it's not. Let me show you this one. Two. My dead one. Okay, 2/3, and there's an x plus 12 in here. 2/3 of what would be 10? 10 is 2 parts, so each part is, so what's all 3 parts? 10 is the two of the 3 parts. 2/3 of what? Candy bar method. 2 parts make 10, so each part was 5. I know candy bar sounds dorky, but sometimes dorky works in math. Okay, so each part was 5. So then all 3 parts is, if each part is 5, then all 3 parts were 15. So 2/3 of 15 is 10. So what's inside of here had to be 15. Therefore, what's x? The whole thing is 15, so what plus 12? Yeah, 3. Okay, will that make your brain go forwards and backwards? Yeah. Is that part of what strengthens your brain? Yes. Okay, that's okay then. If you would, let's have you come over here. The students, please. Let's have somebody here. Would you pull over that chair, please? How about you two gentlemen sit down? And you read off the problem to them. 2/3 of what is 20? And if you can say 2 times what is 20?
Okay.
10. So then 3 parts would be, and they'll figure it out, and you'll have the answer. Okay, so then I'll have, I can be the card flipper, but I like to let students do. Okay, pull up another chair, go ahead and take a seat, and you ladies get to do, okay?
Redo it.
Yeah, no problem. 2 parts made 20, so each part was, and then they'll say 10. So if each part is 10, how much is 3 parts?
Okay.
And they'll make them think. And never mind, you have 10 adults all watching you. Just kidding. Okay. 3 parts made 33. So each part was 11. So all 5 parts together would be 11 times 5. You got 5, 11. So you have
55.
yes. 3 parts made 27. So each part was, and so then all 5 parts was 5 times 9, which is 45. That's what you were going to say. Okay. So, you know what? Go at whatever speed you want. But I want you to do that method. Cover it up. 5 times what makes 45? Say 9. So each part is 9. So then you can take your finger off. 6 times 9 is,
Times 9 is something that I suck at.
do you know your nines? Like,
22.
yeah,
No, wait.
6. So then it's
56.
54, yes.
66. Yeah, because they're both the same number, so they have to stay like the exact same the entire way up.
Okay, I want you to use it. I'll put all this away later. I want you to notice the origin, the 0, 0, and then 1, 1, 2, 2, 3, 3. So I want you to put your line on the 0, 0, 1, 1, 2, 2, 3, 3. It also ends up being on the -1, -1, -2, -2, -3, -3, etc. Okay, so that is the graph of y equals x, because the y is a copycat of x. Okay, so that's what y equals x looks like. Now, if you have y equals x plus 1, if x is 1, we're going to do y equals x plus 1. Okay, we're going to have some x numbers and some y numbers. Okay, 0, 1, 2. If it works, that's good enough. Okay, if x is 0, 0 plus 1 is 1. 0 plus 1 is 1. If x is 1, you add 1, and that's what y is. So y would be 2. If x is 2, and you add 1, you get 3. So then your ordered pairs would be at 0, 1, 1, 2, and 2, 3. Okay, so I want you to put your linguine on that. So 0 up 1, 1, 2, and 2, 3. Okay.
Wait, 0, 1, and what was the other coordinate?
Okay, 0, 1, then 1 over 2 up,
Wait, just, can you say the normal coordinate? 1, 2?
0, 1. Okay, 0 over left or right, but up 1. Yeah,
0,
1.
1.
And then 1 over 2 up.
Wait, so is it negative? Wait, 1.
Don't do negatives unless you have to. That's my thinking. Seriously, if you can do math without negatives, more power to you. Negatives, in my viewpoint, are way overemphasized in math nowadays, way overemphasized.
Your graph is not facing you, it's facing us. I thought it was facing you, so that's why I thought it was negative. Based on where
Okay,
you put the
yeah,
points.
yeah, okay. No, I've been a teacher and tutor for so long that I do things upside down. Okay, now, notice y equals x was right there, and y equals x plus 1 is exactly above it. Ooh. Put a linguine on y equals x yet. Y equals x went through 0, 0, 1, 1, 2, 2, 3, 3. What do you notice about these two lines? They're parallel, which means they'll never meet, never touch, all your geometry people. And if they happen to go up, y equals x, they happen to go up at the same rate, 1, 1, and then 1, 1, 1, 1, 1, 1, 1, 1. So they go up at the same rate. What's that rate called? Slope. They slope at the same one. Now I want us to do y equals, leave those on, y equals x minus 3. So you can make your little graph. We'll do 4, 3, and 2. Okay. If x is 4, 4 minus 3 is? 1. If x is 3, 3 minus 3 is? 0. And if x is 2, 2 minus 3 is? Negative 1, because you know your negatives now. Okay. So 4, 1, would be 4 to the right and then up 1. And then 3, 0, 3 over to the right and then nothing. Oh, do your dots, because you're already one step ahead of me doing it. Did you grab one? Go ahead and do the dots on these ordered pairs. 4, 1, 3, 0, and then 2, -1.
Wow, I forgot how to count there for a second. Nope, that's not right. Okay.
And then put another linguine on. Oh, that's fine. The nice thing about these is that's also your eraser. So that's kind of cool. You can clean it off, which is why these are like automatic whiteboards as soon as I put it into a sheet protector. Cool. So what do you notice about your third line?
It's different.
Parallel, and you've got it drawn. Your other two are not in the right place, but that's okay. They're still slanting at the right rate.
Oh, yeah.
No problem. You got 3 parallel lines, and they all go at the same slope. And then notice they all started with y equals x. Y equals 1x, you can think of it as. Whenever it's y equals 1x, it's going to be somehow parallel to the original y equals x. Just is. Now, put your linguine up, and let's do another one.
Should we have these?
What if you have y equals 2x? Okay, x, y, stay with positives if you want to. Okay, 2 times x is whatever y is. So 2 times 3, the y would be?
6.
And 2 times 2, the y would be?
4.
And 2 times the 1, the y would be?
2.
Okay, so using your marker, go ahead and make your dots. 3, 6, 2, 4, 1, 2. Oh, there's no 6, sorry. Make one. That's good. Okay, 2, 4, and 1, 2. Nope, that looks good. It's not supposed to be parallel to what we had. And 2 over and 4 up, and then 1 over and, oh yeah, okay. Yeah, and 1 over and 2 up, yeah, 2 up, yep. And then you put your linguine on it, and okay. Does it still go through the origin?
Oh, there we go.
Yes, it does. Okay, sorry. False alarm. Okay. Yep, and 1, 2. Then you put your linguine on it, and you got it. Okay. The slope is 2, and the y-intercept, you know how there's y equals mx plus b? What's that called?
Slope intercept form.
Yes, it is. This one has no b, which means it has 0, which means it's going to go through the 0, 0.
Yes.
And then from there, it's going to do whatever slope tells it to do. This one said, go up 2 over 1, up 2 over 1, up 2 over 1. That make sense? Okay. Think you got the hang of this? Can we do something else? Okay. I have your permission. Good. Okay. I'll take all of this away, no problem. You can go back to your seats. Your last page has the slope-intercept form, y equals mx plus b, which I just asked you about over there. That is like one of the most profound things you're going to learn in algebra, and you'll relearn it as some in geometry, and it'll be on your ACT test and your SAT test. So using it will be. So at your age, just practice and practice and practice. So let me know, and once you're on the internet, go to monumentalmath.com up there, please. That's my website. It's free. And in the upper right, it'll say sign up. So you just give an email address, can be yours or your parents. Okay, and then you give yourself a username and you give yourself a password. A password you'll remember, and I would say write it down. The only reason I ask for an email address is if you say, I forgot my password, we have to have a way to give you a notice that you may go in and change your password. Here's a link. That's the only reason. I don't sell the email addresses. Somebody said, how do you make money on this website? I don't. So it's just truly, like when I was volunteering at schools, I wasn't making money. That's okay. Why is that a hard concept? I think it's fun to help people. Okay, so you got your 4 categories. Math Foundations, I want you to tap that, and you'll see a whole long cascading list of a lot of topics. And then touch one of those topics, and a whole nother list will show up, and that shows how many sets of problems there are. There's 25 problems in each one of those problem sets. If it's a more minor topic, then there's only 2 sets. If I think it's more important, there's as many as 10 sets. Like simplifying fractions, 10 sets. Okay? And then as soon as you pick another one, it'll show you how many sets of those and how many sets of those. So like when there's 10 sets, 25 in each set, there's 250 problems just to practice simplifying fractions, because that's an important topic. Okay, if you go to challenging math, I used to, when I taught and when I volunteered in middle school, I would help coach the kids for the math contest called Math Counts. And so I know there's kids in the classroom that just love a challenge. So I had to invent a part for that. Then let's go to algebra and then geometry. In the algebra, you're going to see it's a long list again. There's, I think, 93 sets, 93 topics maybe, and then there's lots of sets. Yeah, okay. So, and if you would go to the 2 steps with whole numbers, go ahead and go to that and go to set 1. You want me to sign in as me? Let me know. Okay. Okay. And if you go to set 1, it'll be like those problems that we were doing on your paper at the very beginning. I try to stay with positive numbers as much as possible, because I think in regular life, you don't use negatives much. My husband's an engineer, 2 of my kids are engineers. They went through lots of calculus and all kinds of stuff, and they hardly ever use it. So when kids say, why are we learning this? I do think that's a valid question. To me, my best answer for you is that it expands your brain to be able to do more things and hold on to more things. It teaches you to be analytical, teaches you to look for certain things, focus in and do the next step. Focus in, do the next step. And that itself of being able to look at something and know what to do, that is definitely a real life ability that you'll want. So I stay with positives because if I want to teach you to be analytical, let's do it in the least painful way possible. Now, and there's a lot of times there's my videos that I mentioned that I do, and I explain exactly what this is. You don't have to read. A teacher said, man, people don't like to read nowadays. They'd like to have videos. Okay, fine. So I hired somebody to make little videos for me. Okay. Okay. Now let's go back up to monumental math on the upper left. All that does is it brings you back to the home page. Okay. I want you to, we're going to do some very easy stuff for you, and you'll see why. So let's go to algebra, the very first topic, one-step equations with whole numbers, and let's do set 1. Try this means you didn't have to sign up for it. You could have tried it without signing up, but you're all signed up. It's free anyhow. Okay, so the first problem is x plus 39 equals 44. Think money. If you have $39 and you want to get to 44, you still need 5. So you press 5, submit answer, and this bar grows. That's your progress bar. If you have 48 and you want 58, your x is 10. Now let's get one wrong, and I'll show you. Choose that first one. People, no, let's choose the first one. Oh, you were going to choose the wrong one. Okay, submit, and it's yellow. That's your caution light. Oh, what did I do wrong? So then you go, okay, what plus 12 makes 15? X equals 3. You push submit, and it pretends it never happened. So that's good. And life goes on. You're at 34. Actually, stop that. Go back up to monumentalmath.com. Go up to there. Brings you back to home page. Okay. Let's go to geometry, the first topic, and find the measure of the third angle of a triangle. Set 1. Okay. I look like I'm asleep. Whoops. Okay. If I give you 2 of the angles, you can always find the third, because what's the grand total of the angles of a triangle? What does it always add up to? 180. So if one of them's 30 and one of them's 50, that makes a total of 80. So what's left to be the third angle? 100. Next one, 50 and 100, that's a total of, therefore I still need, yes. That kind of transitive thought is a part of what you do as an adult in life. This and this, then I need this, or whatever. That's a good thing. 30 and 100, so I already have 130, so my other angle must be 50. Good. Now I want you to, we're going to stop. Go back up to Monumental Math, so it takes us back to the home page. And then let's go to Math Foundations. Let's go down to Mental Math Addition. This will be really easy for you, but that's okay. You're going to see why. Okay. 4 plus 3 plus 6. It just so happens the 4 and the 6 make 10, plus the middle number it makes. Okay, if you're in first grade, this is a challenge for you. Okay. So go ahead and do the next one. This is one of my apps too. 2 plus what makes, and then plus 4 makes, and they dress a teddy bear. Okay. Yep. And then let's go back up to Monumental Math, and we'll do one more. Let's go back over to algebra, and let's go to the 2-step equations with whole numbers, set 4, because you're ready for it. 2-step equations with whole numbers, it's just a little harder. Each one might be a little harder. Oh well. Something got divided by 9, and then they subtracted 6, and you got 2. If you cover up that x divided by 9 in your head, what minus 6 gives you 2? What minus 6 gives you 2? 8. So x divided by 9 must be 8. What divided by 9 leaves you with 8? 8 times 9, which is? How much?
6. 8 times that?
Yep. Because what minus 6 gives you 2? 8. So x divided by 9 has to give you 8. So multiply 8 and 9, and you get 72. See, I told you it'd be a little harder than that set 1. Okay, so if you mentally cover up that fraction, what plus 6 makes 10? 4. So then what divided by 8 will make that be 4? 4 times 8, which is 32. Okay. Then what subtract 4 leaves you with 2? 6. So that fraction has to make 6. What divided by 9 gives us 6? So 6 times 9. 6 times 9, you don't have the 9s. 54. But let's choose a wrong answer. And let's choose a wrong answer again. You don't have to, but you will. Okay. And let's choose a wrong answer again. It turns red, but it just moves on. And the reason my thinking for putting that in is, yeah, you got one wrong, go on to the next thing. You probably learned, oh yeah, and then you move on. Because we get things wrong in life. Well, okay, So now I want you to go to problem sets. Right next to monumental math, there's problem sets. I want you to tap that. And if you've been doing what she's been doing, you'll have this all in there. Go over to problem sets, across the top there, right next to monumental math. Yep. And then go to my progress. And it shows you everything you've ever done. It shows you the title, it shows you how many problems you have completed out of a possible 25. So far you have that % correct, and it tells you your time. If you want to complete it, that first one, it says I've got 3 problems done. So let's push complete, and it'll bring us to problem number 4, because it knows you have 3 of them done. And then you just keep going. It has the time in there. Some of my students, the first times they're going through it, I use this when I tutor. Some of the time it takes them, they're a little clunky on going through it. And then they say, I want to try it again because I want to beat my time. Cool, that's right, and I always let them. But that would be a way that you can use that information to help you. So it was on problem sets, my progress. Yep. Now, go to problem sets, and it drops down, and the first thing, it says search problem sets. So I want you to do the same thing. And it'll give you search for problem set. Type in, no, at the top, type in identify graph. Identify graph. Yep, and then just push search, and it'll show you all my titles that have that. Okay, here's identify the equation given the graph, and here's the opposite, identify the graph given the equation. So let's go to identify the graph given the equation set 1. Yep, do problem set. Okay, let me know, raise your hand when you're there. So it was on identify the graph given the equation. A couple of people are there. Let me know when you got it. You got it? Okay, got it. And are you there? Cool, all right. It says identify the graph for this equation. Y equals x, so that's y equals x, 1 over, 1 up, 1 up, 1 over, 1 up, 1 over, plus 4. It has to go through a 4 on the y-axis, and positive x, so it has to slant up to the right. So let's scoot down. That one does not scoot up to the right. That one stops at 4, but it has the wrong slope. That one goes up 4 over 1, so keep going down. That one slants up to the left. That's wrong, so that's negative slope. So it must be the last one. And that one has a y-intercept of 4, and the other dot, from the other dot to the second dot is up 1 over 1, up 1 over 1, so that's it. So you press that little circle up there, and you bring it down, and you submit, and it'll do the next one, y equals x. That was what we did with the linguini. So there is no plus number on it, which means it goes through 0, 0. So that one does not go through 0, 0. That one goes through 0, 0, and the slope is 1 up, 1 over, 1 up, 1 over, so that's it. That's the one we want. Yep, and then you submit, and we'll go on to the next one. Okay, to me, I like things that aren't necessarily pencil paper, but you're still learning. And to me, I would like this to be very helpful to you. In a short while, you can do a lot of problems. I just tutored before I came here, and that was a 5th grader, and she did 100 problems on the problems on the website. And she also worked on one of my apps, and she also did 2 other activities that I had. She can just keep clipping along. This one has y equals 2x, so positive x, so it has to go up to the right. It does not have a number, so it does go through 0, 0. Not that one, because that one goes to the left. We want it to go to the right. Okay, can you go back up to the equation? I've already forgotten it. Y equals 2x. Okay, so that one It doesn't go through 0, 0, so that's not it. Let's take a look at that one. It goes through 0, 0. The slope was 2, so up 2 over 1, that's it. Okay, so go ahead and choose that. Submit. Y equals 2x plus 2. Positive slope, so it's going to go up to the right, and it's going to go up the y-axis and have one of the dots on the plus 2. So it's got to go up to the right. They went to the wrong direction, so keep going. Okay, 2x plus 2, that looks promising. So from the first dot to the second dot, 2 up and 1 over, so that's it. Yep, y equals 2x plus 2. Okay, next one, y equals x and minus 2. So let's take a look at that first one because it has to, on the y-axis, it has to hit at -2, and that one already does. Y equals x means y equals 1x, which is 1 over 1. So from there, it goes up 1 over 1, up 1 over 1, so that's already it. That's our answer. Ready? Keep going? Okay. Y equals 3x plus 1. Positive 3x, like I said, I do positives a lot more than I do negatives. Okay, so we want 3x, so we want a positive slope, and we want it to pass through a positive 1. So let's check out this one. From that dot on the y-axis, if you go up 3 over 1, it does go through that coordinate, so that's right. That's the one we want.
Where's that up
Yep.
over 1?
Up 3 over 1 from that upper one.
Oh, from the, okay.
Yep. So you can go ahead and check that one. Submit. Okay. Y equals 4x. Notice there's no plus number, so it goes through 0, 0. And 4x means 4 over 1, so you look at this one, you go, goes through 0, 0. If I go up 4 and over 1, does it hit? Yes, so that's already your graph. Okay, now you got this done, or you got this started. So let's go to where it's in the reverse. I give you the graph, and you have to tell me what the equation is. So go back up to problem set, and search, and type in identify graph again. Identify graph. And we're going to go to identify the graph given the equation, no, opposite, identify. So I want to identify the graph. No, we just did that. Yeah. So set 1. Nope, that's set 5. Let's go set 1. Probably by set 5, it's going to have 2/3 x minus 4 or something, so it'll have fractions, which isn't that bad. It's just get used to things where it's simpler, and then do it. Identify the equation of this line. Well, it goes through the origin, so it goes through 0, 0, so it won't have a plus number on it. And if you look for the slope, from that dot, it goes up 1 over 1, up 1 over 1, so that is y equals x. So you go down and you pick y equals x. Goes up to the right. Okay, identify the equation. It'll have positive slope, and it goes through a plus 1. And from there, it goes up and over, so it's still y equals x plus 1. Yep, that first one. Now this one goes through 0, 0, so it's not going to have a plus number on it. So then you have to figure out, okay, what's the slope? From that dot, you go up and over, and you can go up 2 and over 1, and it hits. So 2 over 1, so y equals 2x. Okay, it goes through 0, 0, so you're not going to have a plus number anymore. And if you look for what is a slope, from that dot, from the origin, goes up 3 and over 1, and you'll hit a dot again. So y equals 3x. Okay, this one, it hits at 5, so you're going to have a plus 5. And if you look for what's the slope, you go from this dot to that dot, it's a plus 4, huh? Okay, so it'll have a plus 4. So it went from that first dot, if you go up and over to the second dot, it goes up 4 over 2, but 4 over 2 is like 2 over 1, so the slope is 2. So y equals 2x plus the 4. Yep. This one has a dot on plus 2. So let's go down and just see if there's any that have a plus 2, because that would maybe be our answer. Oh, bummer, we have 2 answers that are plus 2. So now we have to actually go figure it out. From a dot, it goes up 1 over 1, up 1 over 1. So that's y equals 1x or y equals x. Y equals x plus 2, your last one. Okay. Now you go ahead and do a few more on your own.
So, I learned some things. I don't think I learned math like this.
I didn't either.
But again, student, this is your ability to use that website and watch the videos and all of that as she walks through everything step by step and gives you some of these manipulatives that she showed you today. And that I think can help tremendously. So thank you.
Yeah,
for
you
that
bet.
as well.
That's what I want to do, help.